Greetings. Welcome to the continuing saga of the Jaguar Series 3 manual heater control module, which I've been producing for some time. This video is to introduce you to some of the latest versions of what I've been doing, just playing with it. But anyway, one of the fellows had a problem with the L293, the motor driver chip. Apparently something bound in his board, or else he had a bad chip. We don't really know why, but for some reason the chip failed, and it made me realize that if by chance the servo does bind for any reason, maybe a door sticks or a valve, any of a number of things can cause it, or one of the limit switches fail, then the motor basically can draw a lot of current. This little device right here, the L293D, which is the one that we used in the beginning, it has a 600 milliamp running current. Well, this board runs at about 250 milliamps, so basically there's a lot of headroom there. But if the servo binds, then the current can go to many times that, and this little chip will not be able to handle it. So that led me to this, to thinking that maybe putting a fuse on board the module might be a good idea. So this new generation board made two changes. One is I put a fuse on. This particular version has a 1 amp pico fuse on the board. I have this one in standoffs, as you see, but if I use this in production, yeah, right. But anyway, if boards that I sell, this will be actually soldered into the board. If this thing should pop, this fuse, then it'll have to be removed with a soldering iron. But anyway, lately I've also been using a higher current version of this, which is the L293B, and it has a 1 amp running current with a 1.2 amp surge. So the 1 amp fuse will certainly protect that. So anyway, and also I'm parallel in the motor. The L293 is a dual motor driver. So I have this new board wired in such a way that the motor drives through both of those drivers. So basically each one is carrying half the load. So this is the first version of it, and we will continue on here. This is the second version of the same thing. Everything on it is the same. It has the L293 and 741 the same, but it has a 5x20 removable fuse on board. So this fuse, if it should pop, just can be removed and replaced without any fanfare, so no soldering gears available. These chips are L293Ds, and of course they run fine, but I'm using the L293B in any boards that I sell. So that's the second one. The third version is very similar, except that on this one I use the surface mount resistors and LEDs. I didn't know if I could actually solder those little boogers in place or not, but it turns out I can. So it frees up a lot of space on the board, so there's room for other components or to make the board smaller if necessary or whatever. But this one also has the 5x20 1 amp onboard fuse. Otherwise, except the surface mount is identical to the other board. The next one is a higher current version of the board. This one is capable of 2 amps. But like I said, the servo runs at 250 milliamps, so this is kind of overkill. But anyway, it uses relays for the motor drive instead of using the chip. So this is the same way that my original board was done many years ago, and also the same way Delamere did it. They use relays to drive the motor. Otherwise, it's the same. It has a 2 amp pico fuse on board, the same 741 front end as the other. This is another high current version. This one uses TC4420 MOSFET drivers. These chips are normally used to drive the MOSFET, and MOSFETs are capable of a large amount of current. We don't need any current like that anywhere close to it, but these are capable by themselves of carrying 6 amps. So 6 amps is way overkill for what we need, but nonetheless, I just was playing with it, thought I'd see if it would work, and it works beautifully. This board is fused with a 3 amp fuse on board, but it works same way. This one is an experimental board, which I don't have working quite yet. the idea here is it uses this Atmega 328 microcontroller for the front end. So it replaces the 741. This various peripheral stuff. All the inputs go directly into it. It determines which way the motor should drive, and then it drives the 293. So this could be used with the relays or with the other drivers, either one. But this particular board uses the 293. But like I said, totally experimental. I don't have it working yet beyond just kind of half-heartedly. So I still have some adjustment to do with the programming or changing some values. Anyway, we'll see how that works. The last one, this one, as you see, is not populated yet. This board will be automatic. So if I can make this work properly, I have a prototype running, and the prototype seems to work kind of half-heartedly, or actually it works pretty well, but the calibration is the problem. I don't have it calibrated to the proper temperatures yet. But when I have time, I'll play with it and see if I can get it calibrated. And if it works, I'll be able to offer a fully automatic version instead of the manual ones. It's going to use the L293 as a driver for the motor and surface mount pieces over here. So we'll see how that works. So anyway, that's about it, guys. Just wanted to introduce you to the new boards. I'm running short on the other, the last version, so I'm probably going to have to start selling these soon. So we'll see how it goes. So anyway, you guys take care out there. Be safe and happy motoring.